Welcome to Session 10. Here's a powerful idea that unlocks a whole family of angle problems. In a triangle, equal sides come with equal angles. When two sides of a triangle match, the angles opposite them match too. Today, we'll use that connection to find missing angles in isosceles and equilateral triangles. Let's start with the isosceles triangle, which has two equal sides. The two angles opposite those equal sides are called the base angles, and they are always equal. The third angle, at the top where the equal sides meet, is called the vertex angle. So if the two equal sides are AB and AC, then the base angles, angle B and angle C, are equal. And of course, all three still add up to 180 degrees. Let's find some angles. Suppose an isosceles triangle has a vertex angle of 40 degrees at the top. The two base angles share whatever is left. First, subtract the vertex angle from 180. 180 minus 40 is 140. Then split that evenly between the two equal base angles. 140 divided by 2 is 70. It also works in reverse. Suppose you're told one base angle is 50 degrees. Because the base angles are equal, the other base angle is also 50. Then the vertex angle is 180 minus 50 minus 50, which is 80 degrees. Knowing just one base angle gave us the entire triangle. Now, the equilateral triangle, where all three sides are equal. If all three sides are equal, then all three angles are equal too. And since they must add to 180, each angle is 180 divided by 3, which is exactly 60 degrees. Every equilateral triangle has three 60-degree angles. No calculation needed. Here's a subtle but important detail. Equal angles sit opposite the equal sides, not necessarily right beside them. If sides AB and AC are equal, the equal angles are the ones across from them, angle C and angle B. It helps to trace across the triangle. Follow each equal side to the angle facing it. That way, you never match an angle with the wrong side. The relationship also runs the other way. If two angles in a triangle are equal, then the sides opposite those angles are equal too. So you can recognize an isosceles triangle just from its angle markings, even before anyone tells you about the sides. Equal angles and equal sides always travel together. Let's try an algebra problem. Suppose the two base angles are labeled 3x plus 5 and 5x minus 25. Because base angles are equal, we set the expressions equal. 3x plus 5 equals 5x minus 25. Solving, 30 equals 2x. So x equals 15. Substitute back. Each base angle is 3 times 15 plus 5, which is 50 degrees. And the vertex angle is 180 minus 50 minus 50, which is 80 degrees. Here's a real-world picture, an A-frame house, or a simple tent. The two equal slanted sides create two equal base angles where they meet the ground. That symmetry is exactly the isosceles rule at work. Equal sides producing equal angles, keeping the structure balanced. Now, the common mistake. When finding the base angles, students sometimes forget to subtract the vertex angle first, or they split the wrong angle. Here's the reliable routine for an isosceles triangle. Take 180, subtract the vertex angle, and then split what remains in half. That gives the two equal base angles every time. Let's check your understanding. An isosceles triangle has a vertex angle of 40 degrees. What is each base angle? Subtract the vertex from 180 to get 140, then divide by 2. Each base angle is 70 degrees. Let's recap. In an isosceles triangle, the two base angles, opposite the equal sides, are equal. To find them, subtract the vertex angle from 180 and split the rest in half. In an equilateral triangle, all three angles are 60 degrees, and equal sides and equal angles always face each other, so trace across to match them. Wonderful work on Session 10. You can now solve isosceles and equilateral triangles with ease. Next time, we'll take everything we've learned and apply it to real-world word problems.